Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 4 video from the chapter of surface areas and volumes, I will be solving another 5 conceptual problems of set 3 based on the surface areas and volumes of cuboid and cube that I discussed in part 1. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so these problems are based on the supplementary problem book titled MCQs in Mathematics by R.D. Sharma, and few problems are from NCERT Exemplar. The first problem says the lateral surface area of a cube is a meter square, then its volume V is given by. Okay, now the lateral the lateral surface area, which is usually denoted with LSA, it is given as A. So based on the formula of cuboid, we know the lateral surface area is 2 into length plus breadth multiplied by height. Now for a cube, this will be, since for a cube the length, breadth and height are all same, they have the same values, that is all the edges are of same length, which is known as side length. Let's say the side length is A, so this will be A plus A multiplied by A, so this is 4A square. Now if you do a lot of problems, you will probably remember all the formulas of for a cube, which I do not remember. I always try to derive the formula for a cube from cuboid. Okay, now then this implies I will express A in terms of small a, that is the side length, in terms of capital A, that is the lateral surface area. So this implies A will be equal to square root of A by 4. This is equal to square root of A by 2. Now what is volume? Volume I know is equal to, for a cube of side length A or edge length A, is A cube. Now A I know is square root of A divided by 2. So this cube, this is equal to square root of A cube. Now you must be very strong in the laws of exponents to solve this kind of problem from this chapter, that is surface areas and volumes. 2 by 2 cube. Now square root of A to the power 3, square root of A is A to the power half, and applying the laws of exponents, it will be A to the power 3 by 2 divided by 8. So now this becomes 8V. If I do cross multiplication, 8V is equal to A to the power 3 by 2. Now I have to simplify these results so that it matches with one of the given choices. Now the closest match is choice C. Now on the right hand side, it is A multiplied by square root of A. Okay, now so basically initially it was square root of 3 whole cube. So which means square root of A multiplied by square root of A multiplied by square root of A. Square root of A multiplied by square root of A is A. So this becomes A multiplied by square root of A. So the correct choice is C. C is the correct choice. Now as always I say, if you see any kind of mistakes I am doing, I am coming up with wrong answers, or if I am applying wrong formula or applying concepts incorrectly or incorrect concepts, please feel free to let me know in the comment section. I will highly appreciate that. And also if you have any doubt or any question regarding any concept from the chapter, please do let me know. I will do my best to address your query. Let's see the next problem. Question number 2. The sum of the lengths of 3 adjacent edges of a cuboid is x centimeter. Then the perimeter of cuboid is. Now what are the 3 adjacent edges of a cube? The length, breadth and height, they are the adjacent. If you consider any 3 adjacent edges of a cube, they will be the length, breadth and height. So basically it is given L plus B plus H is equal to x. Now perimeter, we know for a for a cuboid the perimeter is 4 into L plus B plus H. So this will be equal to 4x. This was super easy. Just you need to understand that any three adjacent edges of a cuboid are basically the length, breadth and height. So the correct choice is B. B is the correct choice. Okay, let's see question number 3. A storage tank is in the form of a cube. Okay, when it is full of water, the volume of water is V centimeter cube. Okay, if the present depth of water is x centimeter, find the volume of water already used from the tank. Okay, so initially the tank was full of, the tank is in the form of a cube. Let's say, so if I consider the side length of the cube or of the tank is a, then we have V is equal to a cube. Basically this means that a is equal to V to the power cube root of V. So a is cube root of V, which in the rational form or in the exponential form is V to the power 1 by 3. Okay, so a is V to the power 1 by 3. Okay, now if the present depth of water is, so let's say this is the tank, sorry, let's say this be the tank, it is a cube in the form of cube. So present depth of the water is x centimeter. This is the depth, water depth, and obviously this is a, this is also a, since the tank is in the form of a cube, a. Now if the present depth of water is x centimeter, find the volume of water already used from the tank. So we have to find this volume. This amount of water has been already used. Okay, now so what will be the height? What will be, so this will be obviously a minus x, this height will be a minus x. So find the volume of water already used from the tank. So obviously what will be the volume of the shaded region? It will be the length and breadth, they will be same, a multiplied by a, but the height is now a minus x. So this is a square. If I a square multiplied by a minus x, now this is basically a cube minus a square x. Now what is a cube? A cube was v, so v minus what is a square? A square will be v by v to the power 1 by 3 whole square multiplied by x. So this is v minus v to the power 2 by 3 multiplied by x. So this is the volume of water already used. Now we have to simplify this so that it matches with one of the given choices. Now if I definitely choice A is not correct, choice B, if I take, let me see, if I take v to the power half common, if I take v to the power half common from this, from the two terms, so what is v? I can say v to be v to the power 1 by 3 multiplied by v to the power 2 by 3, and we have minus v to the power 2 by 3x. So clearly I can see, I can take v to the power 2 by 3 common, and I have v to the power 1 by 3 minus x. So I can see it matches, this matches with the choice C. So C is the correct choice. Okay, let's see the next problem. Question number 4. A small village having a population of P requires X liter of water per head per day. Okay, so per day each person requires X liter of water. The village has got an overhead tank of dimensions X by Y by Z meter, that is its volume is XYZ meter cube. for how many days will the water of this tank last. Okay, so basically we have to first find how much water is required, is consumed by by the whole entire population per day, and then we will divide the total volume of the tank by the amount of water consumed by the whole population per day, which will give the number of days the water will last. Okay, so what is the volume of the tank? The volume of the tank is X, Y, Z, and there are no choices. I forgot to give the choices anyway. So volume of the tank is the total amount of water the tank can contain is XYZ meter cube. Okay, now what is the, let's say V1 is the volume of V1 is the volume of water consumed by the entire population in one day. So this will be equal to P into X liter. Now this is liter, and we have to convert liter, the volume of the tank we are having in meter cube. Now liter, so if I remember correctly, 1 ml, 1 milliliter is equal to 1 centimeter cube. 1 milliliter is equal to 1 centimeter cube. Now this means, this implies L by 100, L by 1000 liter is equal to 1 centimeter cube. This implies L 1 liter is equal to 1000 centimeter cube. Now I have to convert 1000 centimeter cube to meter cube. Okay, so this means centimeter cube. Okay, okay, so this is 1000 multiplied by 1 centimeter. This is equal to 1 centimeter is 1 by 100 meter. So this is 1 by 100 cube meter cube. So this becomes 10 to the power 3 divided by 10 to the power 6 meter cube. This is actually 10 to the power minus 3. You must be very strong in applying the laws of exponents. So 1 liter is equal to 10 to the power minus 3 meter cube. So Px liter, the amount of water consumed by the entire population per day is Px liter of water, which is equal to Px multiplied by 10 to the power minus 3 this much meter cube. So then the number of days the water in the tank will last will be equal to the total volume of the tank, the total amount of water the tank can store, which is xyz meter cube, divided by the number of water, the amount of water, volume of water is that is being consumed by the population per day, which is Px multiplied by 10 to the power minus 3 meter cube. So this becomes 1000 xyz divided by there is a mistake. A small village having a population of P requires X liter of water. This X is coinciding with the one of the dimension of the length of the tank. So let's say a small village having a population of P requires, let's say not X, but let's say P, let's say something else, let's say P liter of water per day. So this will be small p. No, let's not take small p. Let it be let's say T. So it's a T liter of water per day, per head per day. So the amount of water volume of V1 will be equal to the amount of water consumed by the entire population in one day will then be equal to PT liter, which is equal to P. This will be T. So this will be T. So this is equal to 1000 xyz by pt. This should be the answer. This amount of this is the number of days the total the water will last in the tank. That is, in this number of days all the water in the tank will be consumed by the entire population. Okay, let's see the last problem. If the lengths of the dimensions of a cuboid having surface area of a meter square are increased to k times, the surface area in meter square of the new cuboid is. If the lengths of the dimensions of the cuboid, okay, so let's say we are having the initial dimension of the cuboid to be LBH, that is small length, L is length, B is breadth, and H is height. Let's say the new cuboid is so all the dimensions, length, breadth, and height are increased to k times. So L becomes KL. So the new dimensions becomes KL by KB by KH. Now for this cuboid, the surface area is A, which is equal to basically 2 into LB plus BH plus LH. Now for this cuboid, the cuboid of this dimension, that is the dimension KL, KB and KH, let's say the surface area be A dash, it will be 2 into KL multiplied by KB plus KB multiplied by KH plus KL multiplied by KH. So this becomes 2 into K square LB plus K square BH plus K square LH. I can take K square common from all the three terms inside the bracket, and I have 2 into K square LB plus BH plus LH. So this is equal to K square times A. So the surface area of the new cuboid will be K square A. So with this, it comes to an end in solving another 5 conceptual problem on surface areas and volumes of cuboid and cube. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Probably I will make one more video in solving problems on surface areas and volumes on cuboid and cube, and then I will move on to discussing the concepts and formulas of surface areas and volumes of right circular cone. So please stay tuned for the upcoming videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.